and I'm Sendil. We're going to talk about building a zero trust architecture today. And as I said, I'm Sendil. I'm an engineering manager at Uber, working on payments. And reach out to me if any of this words resonates with you and you want to talk about it, discuss about it, debate about it. Feel free to reach out to me. And I'm available in most of these social channels under that name. So let's start with this. In the current world, it's not something new. We have more organizations are moving towards remote or hybrid work, and it's estimated around 81% of those organizations are moving there. And we are not ready for that, right? 2 years before, we were not ready for that. We are pushed into that. And we wanted, they pushed us out of the luxury of corporate networks that we lived in. So in traditional architecture, everything happens based on where your communication starts. So if it's starting inside your corporate firewall, we basically assume that everything is trusted. But when you move out of that and you're going to work from your home or using your own devices and things like that, the trust from the corporate networks, or the luxury that we had from the corporate networks, you're going to miss it. That is going to be there. You can argue, hey, I'm going to have a VPN, and VPN will solve most of the problems. Of course, yes, VPN can solve some of the problems, but what if VPN gets hacked? What if some vulnerability was there on the VPN? How are we going to solve it? And that's basically what we're going to see today via zero trust architecture. But exposing this traditional architecture, cutting that from the traditional architecture and pasting it in a remote world will not work, and that kind of increases the attack exposure that you're going to have, and which resonates with the fact that we have around 125% increase on the cyber attacks that is happening today. And it's basically because we have this blind trust over something, like for example, if it's running inside your corporate network and things like that, and we have made some assumptions on the traditional architecture side by believing the existing authentication and things like that, and that kind of escalated, and that kind of shows the factor that we have more and more targeted attacks happening. How we can solve it? There's 3 simple things that we can do to solve it. You can reduce the attack surface, a surface in which a hacker or a malicious actor can gain access and work on it. You can reduce that. Or you can limit the lateral movement of anybody. For example, you get hacked, somebody claimed access of one particular domain of your service. You have to limit the lateral movement. They cannot jump it across multiple dimensions. They cannot go from one of your network to another network or another database and things like that. They should not jump across. You should limit the lateral movement. And you should also contain the breach that has happened. So it's basically all of them. If you look at it, it's basically like make your thing isolated, make all the components in your architecture isolated, and work with that. And that's how zero trust architecture also works from the ground. So let's see how it works. The basic fundamental thing that we had so far is trust. You have the trust. Once you establish a trust, you're not going to continuously verify things. You're just going to assume, we trust this breakfast that is coming from this particular person, from this laptop, you're going to assume that. In zero trust, what you're going to do is we're always going to verify it, but never trust. As the name implies, it's zero trust. So we are not going to trust anything. You're going to continuously verify things and how it works. So it's basically like doing any kind of work, like for example, accessing data, doing a deployment, or checking your service status, running your application, and performing an action on your application, and all those things. You're going to not assume anything. You're just going to not trust anybody. You're just going to verify. And that's how zero trust architecture works. So in zero trust, whatever request that is coming or an action that we're going to take, we verify them continuously. And also, even if you're a super admin, you cannot go ahead and delete your user table straight away. You're going to verify that whether you have a particular access, whether you can actually do it, and then we can do that. Make sure that you're doing it correctly. And of course, continuous verification does not mean asking users to log in again and again. User experience matter here, developer experience matter here. So you have to make sure that you have this verification that runs always in the background, and it does not blindly allow anybody to access identities. So if we go ahead on the components of the zero trust architecture, so the building blocks of the architecture, so let's start with that. We'll start with a small example and what are the things that we can do, and gradually build our architecture from there. So let's start with the data. It's a very simple data, and again, in this architecture, data can be anything. It can be the document, it can be a Slack message, or it can be just an email that is sent to you, or a structured data, or anything else. So it can be any data. And But the data actually comes into your system. So you have three different actions that the data can do. First, it can be at rest. Nobody thinks about it. It just lives in your system. The next part is basically it can be a transit. The data can move from one place to other place. And the third part is the data is at use. This is the life cycle of data that is living inside the system. It can be at rest, it can be a transit, and it can be at use. So this is three things that can happen for your data. We should protect our data that is at rest. How are you going to do it? Any guesses on this slide? How we can do this? Yeah, that's true. It's encryption. So encryption is a simple way to do it. And when you do, you just go ahead and encrypt the data with latest technology that's available. Use something like secure vaults for your key management, because when you talk about encryption, there's of course going to be a key. So make sure that you use some secure vaults. I think all the cloud providers nowadays give that secure vault for you, so you can use that. And you have to cycle your secrets frequently. And make sure that you're doing that frequently. And whenever some breaches happen, try to make sure that you're cycling those secrets. And then the next stage is basically protecting your data that is on transit. How you can do it? How you can protect your data that is in transit? Yes, that's good. Yeah, HTTPS and TLS, basic. So you just go ahead and encrypt the data. So whenever your data comes out of your service system or a device or anywhere, whenever data comes out, goes to another place, the entire duration it has to be encrypted using any of these technologies. And you have to protect your data in use. And this is not a new thing. We have something called secure in place, which is in your iPhones. For example, all your biometric data, fingerprint sensor, and all those things lives inside that secure enclave. Nobody can access the data, but it exposes an API with which you can verify and authenticate or authorize the users. Similarly, for a data that is on use, try to have something like secure enclaves. Now, all the cloud providers are providing this trusted execution environment in which you can put your data and it lives inside there. You can store your highly sensitive data with very limited access and provide that access based on some policies. And you can, the data that is going to store inside that secure enclave is going to be cryptographically attested, and it also lives in an isolated environment. So this is a completely isolated environment. It's not like you're putting your JBoss server on one service and then put in different folder, put your cryptographic data over there. It's not similar to that. It's completely a separate environment, very bomb isolated, and the data lives there. Yeah, so we had our data, we encrypted it, and then we kind of the next thing that we have to do is labeling that data. So it's basically like mentioning how critical and how sensitive the data is. And this is the most important step in the data classification that you have to do in a zero trust architecture or any architecture in matter, like how you're going to label that data, whether it's a confidential data, whether the data has a high risk when it leaked out, what is the priority associated with data, and use that information together and label the data as such. Why do we have to do it? At an average, we are seeing around like $4 million plus losses when a breach happens. When your data breaches, it might be in the form of fines, or it might be in the form of like business value, loss of reputation, and things like that. At an average, a single data breach can cost around $4 million plus. And that's a huge sum, right? So we need to make sure the data that we have is correctly labeled. For example, now we have a confidential data. And what's the next step once you have the data? A person should go and access those data. A person should actually take those data. And how we can enable access for them? By default, in a zero trust architecture, we should block everything. We should specifically allow access only after the verification. Without a verification, you should completely block. That's basically the basic stuff or basic step in accessing your data for persons. How we can do it? We can have something like, this is a traditional table that I'm showing here, which has a user role attached to it and a list of access that a particular role can do. And we have this data that's classified and labeled. Based on that label, you can go ahead and assign. For this user or for this role, you can do this kind of things. And the users that we have is going to be authenticated. Once they authenticate themselves, the users will get attached that role. And using that role, you enable access for them. And this is traditionally we call it as role-based access or RBAC. If you're familiar with Kubernetes and stuff like in the cloud native environment, you might have heard about it. So that is what it is. So it's role-based access control that we're going to provide for the data. So user gets authenticated based on the role-based access control. It goes to the data and access to the data is established for the user and user uses it. But we can still streamline it and call it like, instead of having an RBAC, we can go a step further and call it as a policy. We can have a policy that is attached to a data, and this policy actually determines whether you're allowed to access the data or not to access the data. So we're going to call them as a policy, and this is a very simple case, but in any organization, we do not have only one data. We have gazillion of amount of data, right? And this is how we're going to scale. So you have data, you have many data, and each of this data has a label attached to it, and based on the label, you have policies attached to it. But this is too many policies to handle, right? For a simple person, they cannot comprehend how this handling should happen and what we can do. So what we can do as simplify next step is pull out this policy and have a classification as a policy as a separate entity, and all your data is together. So the policy is something that has to be very dynamic. You should have a capacity to dynamically update it, dynamically change the policies as and when required. You have to secure the policy itself, that like nobody can access the policy straight away, so they should have proper role authentication and things like that. All the changes that happens in the policies should be logged, and it should be very specific. So for example, if you're classifying to a particular set of documents or particular set of devices, it has to be very specific, and all those policies should be evaluated periodically. And this is very important. You should not like just assume and forget about it. You should go ahead and evaluate periodically, and that cycle of feedback should be there. So you have this policy, but the determination of whether a policy, with the policy, whether you can access it and things like that, you can have an engine surrounding it, and we could call it as a policy engine. The job of policy engine is basically to ensure the policies that are attached to the data and to the user matches, and you can go ahead and do. It does the exact work that is required. So the basic thing about policy engine, it's going to validate the rules, and it will decide whether you can access, and it's kind of your brain of the entire zero trust architecture, which determines whether you can access or not. And it's a single point for decision making. And the policy should be easy enough to comprehend for all the folks who are doing or working on the policies itself. They should understand it. And we can couple these things together, policy and policy engine together, and we can call it as a zero trust policy. And that is where the core and the brain of the system remains. The very next thing is you need somewhere with which you can control those policies, right? You can manage them, or you can dynamically enable and disable those kind of things. And that's where Policycontroller comes into picture. The main aim of policy control is enabling you to add, edit, delete the policies and things associated with it. And the Policycontroller's main job is governing or making sure that policies are compliant, and you can optimize and assess things better. And the Policycontroller should also have the capability of dynamically allowing or revoking access based on the policies that is required. But that's how it works. But on the other hand, persons cannot just be human beings there, right? It can be bots. It can be any actor in your system. It can be an alien too if it's required, if your services expand to that level. But it can be anything else. So we can call them, group them together and call them as an identities. So the purpose is identities are something that can access to the system and that has some role attached to it, so that it goes to the policy engine, and based on the access it is provided, it executes and allows users to access the data. And that's the simplified version of what you see, few components of the zero trust architecture. So identities, it can be anyone. They can use passwords, they can use MFAs, they can use SSOs to authenticate themselves. They can continuously verify the identity, and we are going to log everything that an identity is going to do. And we are not going to assume any privileges or access for that particular identity. Everything has to be explicit, and it has to be verified continuously. So next stage is like identities do not go and talk to your services straight away, because identities are just an abstract way of looking at data. As a person, we need something. We need a computer or a server through which we can go and access. Similarly for the bots, it needs some server in which it has to run and go and access the data. And that's where a computers and servers comes into picture. And these computers and servers, we're going to call them as endpoints. And these are the endpoints with which it goes and accesses the particular data. And we need to ensure that these servers, these computers, whatever the machine that we're using, we're not using Windows XP for accessing the critical data because it has a lot of loopholes in it. Or we are not using any legacy system. We're going to say them to, hey, your software version should be this version or about that version in order to access it. If it's some known vulnerability that we have, how are we going to manage it? What are the things that we have to do? So it's kind of that kind of policies that are attached to a particular endpoint itself. So that is what endpoints is all about. Why? So we are going to prevent, with endpoints, we are going to prevent vulnerable and rooted devices. We already knew if it's a rooted device, you're not going to give access to your company proprietary information. How we can prevent that? Because we are talking too much about bring your own device, but how you're going to enable that the device that people are bringing is up to date and it does not have any malicious actor inside it. And how you can log all the activities that is happening inside an endpoint is accessing. And you also have to have this baseline activities, which is basically like saying, hey, if you're macOS 12.3 plus, you can access my service. If you're Windows 11 plus, you can access these kind of services. So these kind of baseline activities should also be there, which enables this endpoints to access the particular data. And it's not only about data, right? Data is an abstract thing again. You can access data in multiple different channels. You can go ahead and go to your database and say like select star show all users, but you can also come back and use an application for that. So application is abstraction on top of data, which can access all the things for the data, or it can have some other APIs with which it connects to any other places. So your applications also need some policies. And the applications and data can interconnect each other. So application can be a person, can be a thing that kind of fetches the data and shows it to you. So there is an interconnection between application and data. So applications, they should also have some policies attached to it. And they should provide an in-app permissions and roles for the policies. And you should also log everything that is happening on an application level. So an application can log multiple data, but you should log all those things that it can access, have a policy on top of it. So all the components that you see in this slide has a policy surrounding it, and that policy is controlled by zero trust policy. And finally, you also have infrastructure. So applications cannot run on an ether, right? It has to run on any cloud or any other else, but that's what I'm going to call as an infrastructure over here. And this is where you run your application, and you need to have access to those application and data via this infrastructure. So on infrastructure, it's a very interesting thing when you take a look at infrastructure. How you see data and how you see infrastructure are two different abstract things. But in the infrastructure side, you have to have more stricter policies, like providing just-in-time access for any deployment. So if you're going to do a production deployment, for example, today, you're just going to have that deployment access only for that certain period of time. You're not going to provide access beyond that certain period of time and certain actions that you're going to do. And you can automatically log and flag risky behaviors there. For example, if you're seeing someone is dropping the main table, you could go ahead and block and fix that and flag it before they take that action. If this was there, I think like last 1 or 2 weeks, we would not have seen the bigger Jira issue that is happening where they just dropped all the production application. We might have seen this. So it's basically like automatically block and flag things that are riskier. Log all the activities again. So every stage of or every fundamental block of security or in the zero trust architecture, you will see this consistent point where like you're going to log everything that happens in the system. And fix outdated VMs, audit the things that you're working on. For example, if you're using Kubernetes, if there are any CVEs that was established, fix it and roll it out. And do things on that top of it. So always try to fix the outdated virtual machines and any external tools that we have. And infrastructure and application together, they form these deployments. And this is something really interesting. This deployment can be a binary stuff or FileZilla, opening a FileZilla and pushing those HTML and CSS file into the server and making sure it's reflected on the website. Or it can be anything else. It can be a plain old jar that we are using. And you have to attest the binaries or anything that you're going to deploy. Make sure that this deployment is verified. And it also stands into the components who are sending it, it's integrated, and it's also like it has not changed at any point of time, or any middleman can interrupt and change the data there. So it's basically like you have to ensure the deployments are perfect. And we have some tools, for example, GCP has something called binary authenticate authorizer, which kind of helps you to authorize the payload that you're going to deploy into the server. So this is also an essential step in a zero trust security environment where you have to push things that are verified and that is authorized and authenticated. So all these access, everything that we have seen so far is going to run on top of your network. And that is the fundamental entity that you have. And your network should be private or public. It can be private or public. It can be anything.
And it also needs to have a policy attached to it. And it also needs to have certain restrictions attached to it. So whoever lives on the network, whoever uses the network, has to have that fundamental policies and whether they can access it or not, and we have to consistently verify them. And again, like this, going back to the policy controller, so the network also logs all the activities and it goes back to the controller itself. So as I said before, in the network, anything that transfers inside the network, it has to be completely encrypted. Network is one of the easiest places for hackers to jump in and try to access something, because we kind of use a lot of legacy tools there. So we have to ensure that we have real-time and dynamic threat protection. We log all the activities, as we said before. And it's also like once someone gains access to your network, it's easier for them to move laterally across your network. So they can jump from network to a data, they could figure out what kind of database you use, and they can jump it over there, or they can go to your applications, jump and use the vulnerabilities on the jar or Java code, whatever that you have. So we have to make sure the networks are isolated and segregated such that it makes it harder for anyone to move laterally across the network. And finally, we have this last component that we have here, which is threat protector. So this is nothing but an intelligent component that sits there, which kind of ingests all the logs that you've thrown at it and continuously monitor the policy execution and also access that is happening and flag if something is wrong and things like that. So this is that intelligent component that we were talking about, which takes actions based on what are things happening. So it's basically a threat intelligence component. You can have something simple as like an ML model, which kind of says like, hey, if there is some anomaly that is happening, just escalate it and do it. And threat protector is also kind of a forensics. So it's basically like it ingests all the logs that is thrown into you. So it kind of makes sure it's some kind of an audit log, and it automates the response that we have. And the threat protector also has to continuously assess the policies and ensure the policies are correct structured and verified perfectly. As you see, like we set a lot of logs here, a lot of places we have talked about logs, and that's where telemetry is all about. So you have a couple of telemetry components here, which takes care of everything. So the main function of telemetry is like monitor and enforce zero trust and make sure that you have an intelligent analytics here and there. So that's basically what we have overall. And this is what we call it as a zero trust architecture. Any questions so far? No? Okay, let's move forward. So on the zero trust architecture components itself, you have seen these three things, which we call it as infrastructure, data, and application. These are nothing but your data plane. So this is where all your data lives. This is where everything is handled. And then you have the threat protector, policy, and telemetry, which is kind of brain or the main functionality of your trust policy. And this is what we call it as a control plane. So you have a control plane, you have a data plane, and then finally you have some actors on it. So the actors here are your identities, the network, the endpoints, and all those things that we've seen. And if you think about, if you take a step back and think about it, like how this is architected, you could really see similarities between this and Istio, or any service mesh for that matter. So in the service mesh world, you have a data plane where all your data lives, and then you have your control plane, which is the brain of the entire system, which does all the activities that is required, and it's controlled via that control plane. All these things on the data plane is controlled via that. And you have few actors, basically the identities, the network, and all those things. So what you call is an effective zero trust model. When you talk about like all those things, like there is this component which goes and talks how things work. This is the entire zero trust architecture. So you see a lot of different components that kind of interact with each other and try to build a robust policy and use that robust policy to continuously verify and do things. But how can you make sure that this is effective? What are the things that is required to make this zero trust model more effective? And there are 4 things that was highlighted. So first thing is define context. It's basically like understand the users, how they use the data, and label them. The labeling of data is pretty essential, and also create a trust boundaries between those data. So it's basically encrypting, labeling, and adding access to your data based on policies. And the next step is verifying and enforcing. So in this scenario, you're going to continuously verify whatever that is an user is taking, what are the action the user is taking, and also consistently check. Next thing, you validate all the access that is provided and continuously monitor it. And you ensure that the right access is provided to the right resources for the right people and all those things. If you feel any anomalies that is happening, try to remediate that. And that's your verify stage. And the next one is resolve incident stage, where how fast or how quickly you could resolve an incident that is happening. Whether you can immediately revoke the problem that you're facing, whether if you see some bad actor is using something that they should not see, how fast can you react to it? What is the time it takes for you to react towards there? How can you create an issue automatically? For example, something bad happens, create an issue automatically and try to add it to the users. Try to build a case for that and start a compliance check based on something bad has happened inside the system, how automated you are, and how fast you can do that checks. That is very important on resolve incident stage. And finally, it's a very important thing. You have to analyze and improve. You have to read what is happening, evaluate the policies as it happens, adjust them when it's needed, and also improve that based on whatever that is required. So the next part is basically we're going to subdivide the zero trust architecture into 3 different stages and see where you lie and how can you move to the next one. The first and foremost stage is basically 0. So it's basically the 0 stage of zero trust architecture. The next stage, I would like to call it as a hero stage, where you have something working on, but you still not achieved. And the final stage is what I would like to call a superhero stage, where you could reach that particular entity where you are completely a zero trust architecture environment. So in the world of zero trust, for an identity, you need at least the bare minimum of like password authentication. If that is not there, then it's not even in zero trust. But in hero stage, you might add in like MFAs and SSO authentication. And it's like on the SSO MFAs, we have an interesting factor, like if you have an MFAs enabled in your system, you have less than 96% of getting hacked. And that is a huge number. So I think as simple as a second factor authentication makes it much more easier for you to navigate in that world. And the next stage is basically going passwordless. From having a password and going passwordless is quite a different thing. But if you reach that stage, then you have a system that is completely ready to work on a remote world. The next thing on a zero stage, on the endpoints that we talked about, it's on-premise device management. How many of you use the company-used laptop? Most of them, right? So how can we make sure that we have those on-premise device works perfectly? On the next stage in the hero, it's like cloud device management. How can you make sure that we move that into cloud levels? And the third stage, on the superhero stage, you have to enable bring your own device. And how many companies are comfortable with doing that? And that is the major thing that we want to shift around. So when you go in this direction, which means like we basically added the compliance check that is required for all the endpoints that we are using. The basic necessity for logging and telemetry, you have to log everything on the zero stage. But the next stage, you can log them and automatically highlight the risks that are associated with it. Try to make sure like if something goes happen, it's very simple like outlier detection. If something is outlier, bring that in, notify users, and ask them to act on it. On the superhero stage, you have to automatically fix when things go wrong. When things go wrong, this entire system should be super controlled such that it gets the feedback and puts it in the loop and makes your user to change things around. On the case of data, labeling is very essential. Access providence is also essential. That is a basic thing that is required. But on a hero stage, you can restrict and add in automatic labels. For example, if you're continually adding the same kind of data, you can actually automatically label them instead of like manually doing the labeling part. So you can go ahead and do that. And finally, you can have this proactive data governance where you can proactively govern the data that is coming in and out of the system. On the threat production level, if you're just starting it around, you should have at least a reactive threat detection model where manually someone can raise a concern and you can go forward and fix it. On a hero stage, you can proactively find the threats and enable a manual action as required. So the difference here is like you need to have a manual action, but the detection part is kind of like much more easier and it's automated. On a superhero stage, you have to fully automate the entire threat investigation and fix them. So that is basically what is required on the superhero stage. Cool. So the final part of the session. So the best practices, a few of the things that you can do to enable that you have a best zero trust architecture. First thing and first and foremost is like, never assume roles or privileges. How many of you blindly assume that, okay, this person is a super admin, we are going to have given access to that particular resource because this person is super admin. We all do have that system, right? It's not Linux service that we just put sudo before recommend and run everything out, right? So we have to be very, very critical about how you're giving access, how you're giving roles, and a privilege for that particular people. And these three are somewhat different entities. They are not same. So how you're going to do that? And in your system, if there is any assumption that you're seeing, you have to stop assuming that and make sure that you're going forward and fixing that. Be explicit about whatever the action that happens in the system, whatever the role that you're providing to the particular user, and what are the privileges that the person is going to get by being part of that role. The next important thing is like just give just enough access that is required for that particular action or particular thing that a person wants to do. It's always go for the least privileged action for that particular thing, unless otherwise they are very explicit and they want more higher access. So that is basically the fundamental step in Zero Trust, is you have to provide just enough access. And the way in which you provide it is like basically you enable kind of like just in time and just enough access. These two are very important. Like the main example that we see is like, for example, if you're consistently doing production deployment, and if you have an access at any point of time you could take and go put your jar in the production environment without any problem, then I think you should question that. You should go forward and say like, hey, I need to do this production deployment for this time, and I just need access for that. And after that, your access should be revoked. You should explicitly ask for next access to ensure that your production, the thing that you're going to put into production has just in time and just enough access. And after that, you're revoked of access, and you have to regain that access one more time. And that is very essential. And also, you should, if you're asking for, hey, I want an access privilege for doing something, the privilege should be very explicit to the thing that you asked. It should not have any additional qualities. It can have lesser, but it should not have more. For example, if you have an edit access and you want to have a delete access, then that should be two separate things. It should not be one single thing. Editing is not deleting, and these two are different actions. So your action should determine what kind of privileges that you have in the system. And the next thing is basically like just-in-time access. And here it's very, very important when you're talking about deploying certain things, when you're talking about doing some things on the system, you just have to have that just-in-time access. And when the time goes away and you have done your job or the time finishes, whatever the scenario, you have to ensure that your access is revoked. If it's not, you have to capture those data and then come back and do that. And that's basically overview of it. Any questions? Yes. Yes. Yeah, that's a good one. Like the question basically is like, your applications always need all access data for your data, which it's going to use, and how we can revoke it based on that. And the second part of the question is like, when a malicious actor gain control, how are we going to prevent? Okay, makes sense. So for the first one, so the very important thing is like, if your application has access to the data, the first thing is, again, you have to verify this, whether it's really required. If it's really required and the scenario suggests that it's required, then you have to, the next stage is like find out the priority of the data. How priority or how important the data basically is, how risky the data is basically. And if you have answers for these two questions, then the decision will be based on it. If you say like it's very low priority data and I'm not going to get affected by it, then you can enable the access for that particular application and continuously monitor the cycle. Use that monitor cycle to ensure that we are capturing and the access is not going up. If you're seeing any anomaly action like continuous deletion of records or something like that, then you can come back and revoke that thing. That's the first stage. If it's a very high priority data, which means like basically you have to have more robust way of handling it, which is basically like just before you kickstart a transaction, you can provide that access and remove it. But if it's highly transactional data, then you have to make sure that you take the other step forward and have this feedback loop there. So if you're like monitor, capture those logs, and ensure that you're taking automated action based on the thread that was given to you. So that is how you can basically enable it. And I do agree, applications require more actions than how an endpoint or identity in the system should work. And in that scenario, you have to make sure that you have this automated model that kind of ensures that everything is working fine and captures and then flags out if something riskier happening in the system. Yeah. Yeah. Does that answer your question? Sorry. Yeah. Go for it. Yeah. That's a very good question. I think that's very true even in concepts like Istio, where you see a little bit of latency added to it because there is no trust eventually there, which means the policies has to kick in every time as a sidecar when it's running. So similar to that, here also, there will be a little bit of latency that will be attached to it. But that's why we want to keep this policy engine very comprehensive and also very simple. Basically, it has to detect the authentication and make sure that it's going to have it. Make sure that it gives you a feedback or result or yes or no answer for that policy engine should come within a limited time. And that's predominantly the most important thing that you have to manage and ensure like the latencies are low and build the systems in such a way that it doesn't drag a longer time. So the way I see it, the policy execution stuff or the policy engine itself has to be very highly available, and also it has to have very, very minimal latency. That's basically what's the basic expectation for there. But definitely there is a bit of latency that's attached to it. But overall, the gain is better than compared with the latency that we are going to give. Yeah. Mm-hmm. Yeah, I think it's an interesting thing, and also like the more and more we kind of use it, we kind of understand it and then build out of something from there. But right now the rules are like right now what people generally talk about is basically like to ensure that you have that access when it's required and then move forward from there. So there is no other way of like proactively defining, okay, this particular set you can access it or this particular set you cannot access it. That's something like that, we don't have it. But more in general, if you take a look at it, the other way of handling it is completely other way that we currently do in some places, where we kind of like not doing everything very, like eventually we kind of build a system that eventually be consistent and eventually have that results rather than have it right away. Like for example, one of the biggest concerns that we might have is like an user goes ahead and deletes some data, or we kind of lose certain part of data. In that scenario, instead of going ahead and deleting it right away, you can have things like soft delete and making sure that everything is tracked and monitored, and then we did the eventually deletion thing that happens at a later point of time. That's how we can build a system. But for now, for an application to connect with data, it's very essential. If it's required to do all the CRUD operations basically, then we need to have that CRUD operations there, which means the policy should allow those things to happen. But on the other hand, the monitoring is the basic thing that Zero Trust comes in here. So it helps with that help of monitoring. So that's basically, sorry, my answer is exactly similar to the last one, but it's how we kind of like manage it here. All right. Yeah, and that's basically it. And always verify, but never trust on a Zero Trust environment. That's it. There are a few sources. I'll also publish the slides, so you can also go ahead and look at it. Thanks.